Hello. Today, as usual, we'll continue from where we stopped in the basic operation and indices. So here on the board we have some handfuls of questions which I will lay my hands on. So quickly let's go into operation. Now the first question there, let's look at this. Example, I will pick them randomly. Example 1, if 18 raised to the power 2 over 3 times 12 raised to the power 1 over 3 is equal to 2 raised to the power m times 3 raised to the power n. Say find m squared minus n squared. So this is like the equivalence indices. This is equal to d. That's the meaning. Like some of the questions we did, the previous questions. So here, what we quickly do is this 18. Let's express it as the prime numbers. So this number will express them as a prime number. So this 18 here is 9 times 2 raised to the power 2 over 3 times here, this is 4 times 3 or raised to the power 1/3. Okay, so here this 9 we can also express, this 4 we express it, so this becomes 3 raised to the power 2 times 2 or raised to the power 2 over 3 times the 4 is 2 raised to the power 2 times 3 raised to the power 1/3. So they are equal. 2 raised to the power m times 3 raised to the power n, 2 raised to the power m times 3 raised to the power n. Okay, now we know the law of indices. All this power will affect everything inside this bracket. So this become 3 raised to the power 2 times 2 over 3 times 2 raised to the power 2 over 3. Because here is 1. Here is 1. Okay. Times this bracket here, this is 2 raised to the power 2 times the power 1 over 3 times 3 raised to the power 1 over 3 is equivalent to this. Okay, we group them now. First and foremost, this is 3. 2 times 2 is 4. This is 4 over 3. We bring this one times 3 raised to the power 1 over 3. This is 1. Then 2 raised to the power 2 over 3 times 2 raised to the power 2 over 3 is equivalent to 2 raised to the power m times 3 raised to the power n. So here you see there's some similarity here. So since the bases are the same and the same sign here, you take the base as one, add counts. So here we have 3 raised to the power 4 over 3 plus 1 over 3 times 2 raised to the power 2 over 3 plus 2 over 3 is equal to 2 raised to the power m times 3 raised to the power n. So since the LCM, they are the same, the denominator of these powers, or the fraction of this power are the same, you take them as 1. So the LCM will be 3, 4 plus 1 times 2 here, LCM is 3, 2 plus 2. So here we have 3 raised to the power 4 plus 1 is 5, 5 over 3 times 2 raised to power 4 over 3 is equivalent to 2 raised to the power m times 3 raised to the power n. So here quickly If you look at this, this is to this, while this is to this power. So your m is 5/3, and your n is 4. N is what? 4/3. So what they ask us to do is to find m squared minus n squared. So m squared, which is 5 times 5/3 times 3, which is 25/9. So let's find n squared. N squared simply means n is 4/3. 4/3 times 4/3. That will give us 16/9. So let's do the operation. I say m squared minus n squared. This becomes 25/9 minus 16/9. 25 minus 16, that will give what? 25 minus 16, that gives 9. Okay, so our answer will be 9/9. So m squared minus n squared is equals to 1. So we conclude that m squared minus n squared is equals to what? Equals to 1. That is the answer for that question. Then we look at another question again. Let me pick number 4. Okay, number 4. Here you see if, that's example 2 now. Example 2, if 9 raised to the power 2x plus 1 is equals to 81 raised to the power x minus 2 all over 3 raised to the power x, find x. That's what they ask us to do here. You should find what? X. So here we have to be very careful in our operations. So first, this 9, we have to reduce all of them to a prime number. So 9, 3 squared, 9 means 3 squared. 9, 3 squared. Our 81, 81 means 3 raised to the power 3, which is 3 times 3 times 3 times 3. No, 3 raised to the power 4. 3 will multiply itself 4 times to give 81. So we put it like that. Then we will come and replace 9 with this. And you know 9 also has a power before of 2x plus 1. So if I replace it, this become 3 raised to the power 2 brackets 2x plus 1. So the new power here now, which is 2, we multiply the old power, everything in that bracket. So you come to your right hand side, and this 81 will replace it with 3 raised to the power 4. This is 3 raised to the power what? 4. Open bracket, there's one power there before. We have a power of x minus 2. So the x minus 2 will be written against the new power, which is now 4. You recall this one is a division line. You can say this one is divide 3 raised to the power x. So that so this, what we have here, these two will affect everything in the bracket. So it will be 2 times 2x, that will give 4s. Then 2 times plus 1 will give us 2. So we write here, we come, we say this is 3 raised to the power 4x plus 2. Go to the left, the right hand side. We're done with the left hand side. Here, let's open our bracket first before we do any basic operation. This is 3. 4 times x is 4x. 4 times minus 2 is minus 8. And we're having divide 3 raised to the power what? X. Here, look at it, the bases are common, and we're having a division line, a division sign here. So what we need to do is to apply the law. If the bases are the same and we're having a division sign, you take the base as 1, then you subtract the powers. So we are doing that only to the right hand side. So this is 3 raised to the power 4x on the left hand side plus 2 is equal to 3 raised to the power 4x minus 8 minus x. So 4x minus x, how many x will be left? We'll be left with 3x. So here we have 3 raised to the power 4x plus 2 is equal to 3 raised to the power 3x minus 8. So what we need to do here, having got into these points, we say equate powers. Equate what? Power. With power. So here, if we equate power, that means this one they are off. We are saying 4s plus 2 is equal to what? 3s minus 8. So this has led us to a linear equation of the form, and led us to a linear equation of the form ax plus b is equal to cs plus d. Okay, if you are confronted with this kind of linear equation, what you need to do, you identify the unknown terms, the two unknown terms on both sides. You identify the two constant terms on both sides. You look for the smaller of the unknown terms, 4s and 3x. 3s is smaller. You pick that one first. You look at plus 2 and minus 8. Which one is smaller? Is minus 8. So you add the additive inverse of this to both sides. So now we say add the additive inverse of minus 8 and 3s to both sides. So if we do that, the additive inverse of our 3s is minus 3s. So we have 4x minus 3x. Here we have plus 2. Additive inverse of minus 8 is plus 8 is equal to is equal to 3x minus 3x minus 8 plus 8. So here what we have here s is equal s plus 10 is equal to 0. So our x now, this come to this side, over the additive inverse of plus 10 to both sides. Add minus 10 to both sides. We have s plus 10 minus 10 is equal to 0 minus 10. So our x becomes minus 10. So therefore, s is equal to minus 10. That is the solution to this equation. So we can even check. If we substitute the 10x on the power, you see that we are arriving at the same thing. So we quickly take one more questions, and then we move on. So let's look at this. Look at this. We have picked this. We have picked this. Let's look at this. Okay. So example 3. Okay. Even that's 8 raised to the power 2 minus x is equal to 16 raised to the power 5 minus x. They are equal. So we should find x and x. That is the unknown. Okay, like if, let's express it as a product of its prime in index form, which is 2 raised to the power 3. 16 will be 2 times 2 times 2 times 2 into 4 places. That means 2 raised to the power 4. So we replace 8 with 2 raised to the power 3. So this becomes 2 raised to the power 3. You know, we're having a power here before of 2x minus of 2 minus x. On the right hand side we have a 2 raised to the power 4 open bracket 5 minus x. So having gotten to this point, this one, let's open our bracket first. 3 times 2 6, 3 times minus x is minus 3x is equal to 4 times 5 is 20 minus 4x. Okay, then the next thing, like I say you equate what? Equate with powers. So that means this becomes 6 minus 3x. These are the powers. Is equal to 20 minus 4x. So you can say that add the additive inverse. Look at the constant term minus 3, the constant term 6 and 20, and the unknown term is minus 4 and minus 3s. So between minus 3s and minus 4s, which one is lesser? Is minus 4. So we say add plus 4x and minus 6 to both sides. So here we have 6 minus 3x plus 4x is equal to 20 minus 6 minus 4s plus 4x. See that 6 and 6 they are off here. Minus 3x plus 4x, like I was saying, 4x minus 3x. 20 minus this is a what? It's 14. This one they are blown off. And 4s minus 3s will give us s. S is equal to what? 14. So therefore s is 14. So this one we stop. Each time you are faced with question on indices, the most important thing is for you to know how the logs work. So I would advise you go back to introduction to indices, look at how the logs are related. You must acquaint yourself with the law. That's the only way you can, be able to overcome or resolve questions on indices. Till our next class. Have a nice time. You see some questions yet, there are some that I didn't touch. You can lay your hands on them and see how you can resolve them. Have a nice time.